all on its own by some kind of internal rearrangement of the ecology of beliefs and ideas. So this is kind of a heretical idea for standard economics, but it's an idea that's been increasingly explored by a number of physicists, increasingly collaborating with economists in modeling these kinds of systems. And there are now very interesting and plausible models that show how these kinds of very surprising upheavals can in fact emerge very simply out of systems of people interacting in a market-like setting. So I'll tell you a little bit about how these markets work, these models work, and then I'll finish up with one final example of something even more related to the current crisis, which again shows a similar kind of point. So let's build a toy model of a stock market. So how would you even begin to build a toy model? Well, the first thing you do is you forget what you know about neoclassical and traditional economics. So traditional economics says, how do people make decisions? Well, the thing that sets us apart from the rest of the world is that we're rational, we're conscious, we calculate, we optimize for the future. So if I want to buy or sell a stock, I'm never going to, for example, buy a stock that is already overvalued because I'm likely to lose money. I'm not going to sell a stock that is undervalued. No, people are rational, they make good, accurate decisions, and therefore, in the standard models, this is part of the reason why these models suppose that markets should be in equilibrium, that stock prices should have realistic values and shouldn't really fluctuate too much. To break with this idea, there's a psychologist back in the 70s who said, well, in fact, that's not how people actually make decisions in the world, because we face uncertainty. We can't gather enough information to make good decisions. We don't have time to do all the calculations that would help us to make decisions. What do we do instead? Well, what we do is we tend to rely on lots of little rules, heuristic rules of thumb, ways to make decisions that may not actually be so justified in the world, but we try them, and if they work, we keep using them. If they don't work, then we think, well, that wasn't such a good idea. I'm going to try something else next time. So using this kind of trial and error idea of how people think and adapt and learn, here's how you can build up a model of the market. So I have these colored dots, which are meant to represent market participants. So people in the market come in all kinds of different shapes and sizes. They have different ideas. Some are working for major companies. Some are individuals sitting in their home with their computer, buying and selling. They have very different ideas about how the world works. Some are more optimistic, some are more pessimistic. So you have this big group of people who are going to look to the past record of market prices, this complex pattern of ups and downs, and they're going to try to predict what's going to happen next. And of course, they can't predict this perfectly because it's uncertain. And yet they have to make a decision anyway. There's no choice about it. They have to either buy or sell or do nothing with their money. So what they do is they have a set of possible rules in their head, and they try one particular prediction tomorrow. So one rule might be, well, if it's been going up recently in the past, I think it's going to continue going up. Or it might be, if it's been going up for 2 weeks, I think that's too much, it's going to turn around. People are getting doubtful now. Or they might think, it went up for 2 weeks, and then it went down for 3 weeks, and then up for 2 weeks. I've seen that pattern before. I think it's going to happen again. Right. You can imagine a whole infinite spectrum of possible rules on how to predict the future. Well, the idea is that in a model, you use a computer to develop a kind of artificial market, a kind of virtual market. And in the computer, each market participant is represented by a little computer agent, called an agent, and they're kind of artificially intelligent agents. Each one has maybe 10 or 15 of these possible rules for how to predict the future based on the recent past. And at each moment, they pick one of those rules and they use it. And they either make money or they don't. If they do, they say, well, that rule worked really well, so I'll use it next time. And if it works again, they'll give that even more credence, and they'll use it the third time. If it starts not to work, and they lose money, they'll think, well, I was wrong. They'll try some other rule. So they use this grab bag of ideas in their head to try to live and adapt and survive and thrive in a world of uncertainty. Now the next thing is, so you can build this computer model where you have these, say, 1,000 agents all doing this kind of activity, and they make their decisions. What happens next? Well, after they've made the decisions, of course, this has an effect on the market itself, because these people determine the market. They are the market. So at the next step in this computer model, what you do is you suppose that, of course, well, how do market prices change? It's an imbalance in the number of buyers and sellers that drives a market to move up or down. If there's lots of people trying to buy a stock and few people trying to sell it, its price goes up. If there are many people selling, few people buying, then its price goes down. So this collection of agents uses their bag of tricks, they make decisions, and their own collective behavior then makes the market move up or down. So what you have then is the market is this kind of crazy system of people trying to understand its patterns and making guesses about what it's going to do next. And their very own guesses go together to create the system that makes it do something, go up or down. And then you're on to the next day. The patterns changed a little bit. So you have this ecology of kind of people chasing their own tails, trying to understand the market that they are at the same time creating. Now the interesting thing is you can program this up on a computer, use lots of different agents, give them fairly sophisticated abilities to learn, make mistakes. You can have them copy each other, because a lot of that goes on in markets as well, where one person uses a trick and it seems to work. Other people think, that's working, I'm going to do the same thing. And then you can see what kind of comes out in this model. And what is quite remarkable is that even though these models are extraordinarily simple, the very fact that they incorporate this one feature, which is the adaptability of people, the ability to learn, make guesses, learn and adapt as time goes on, gives a market that has a remarkably realistic feel. So this is a particular outcome from a simulation that was done by a physicist named Neil Johnson at Oxford University, although now he's moved on to Miami University, I think. What it shows is two things. So the blue line is the price of the stock in this model over time. And you see it percolates along up and down in a kind of random way, and then suddenly, about halfway along, there's a sudden drop in the price. Now, in this model, there is no external shock to the system at all. There's nothing that might cause this from the outside. So this is a kind of proof by example of how you can have a market-like system that has really interesting, sudden, abrupt internal dynamics. And all it comes out of is a rearrangement and kind of internal avalanche and change of all the strategies and beliefs and expectations of the people making up the market. It's not an external effect at all. It's just an internal change. But it can be very big and very rapid. The green lines show the overall volume of activity, that is the total quantity of trading on those particular days. One thing I'm not showing here, I didn't want to get into any equations, but the so-called power law and fat tail distributions. It's interesting that many socioeconomic phenomena, in particular markets, show these kind of mathematical patterns all across the board. If you look at the way volatility varies, the way prices vary themselves, if you look at the distribution, say, in how long you can expect a certain business firm to exist, that turns out to follow a fat-tailed distribution that is actually identical to the way species lifetimes are distributed in biology as well. All these kind of mathematical patterns emerge very naturally out of these kind of market models that are built on adaptivity and self-organization and the emergence of patterns in a natural way. And they can't be explained by anything in the kind of standard neoclassical theories of economics. So that's the great promise of these kind of models. So the answer, or one potential answer as to this question of why are the markets so unruly? Why do we have these sudden big events that seem to come out of nowhere and no one predicts? The answer could be that they're not actually being caused by the external influences, but they're being caused by very subtle features of the internal ecology of strategies and beliefs in the system. And I think we're still in kind of the very early days of learning ways to try to probe those patterns and the dynamics of the internal market system. So finally, one more example of how important this can be to market behavior. So there's an event that happened in August of 2007. It's called the Quant Meltdown of August 2007.